Hi, I am K. Vanmathi, MSc MPhil. Hello, my dear students. Welcome to my channel, Max Tutor Vanmathi. By following my videos, you can easily get centum in mathematics. Let us now move on to the lesson.
Hello students, today we are going to see in 10th Maths Unit 1, Section 1.9, it's composition of functions. Composition of functions is nothing but it is type of a chain reaction. That is, already we have seen in arrow diagram, A, B only we have to see. Now we are going to see one more set as C. The function is from A to B is your f function and the function is from G to C is your function G. Two function we are going to write it as f composite G. Clear? Okay, this is based on two functions f and g. So A to B is yes, your f and A to C is your g. Sorry, B to C is your g. Okay, and this function acts one after the another. That is, in chain reaction it goes on like this. No, it will say there will be some connecting. So one after the another it will be goes on. So we can say it is a kind of chain reaction. Next, see, here we are considering two functions f and g. We get from f to g, that is from A to B is your function f. From here x is your input. We are feeding this input to this function, this set B. Then you are getting the output as f of x, and again to for the next g function we are putting the input as f of x and we are getting the output as g of f of x. That why this is given in 2. Example for this composition of functions. Consider the sets A, B and C. Here A is nothing but your students, that is your set of all students appearing for board exam. Okay. For example, consider your 10th exam. For 10th exam, A is the set of all students we are considering and B is your the students roll numbers and C is your for the roll numbers code numbers. Okay. First, for every student who are appearing in board exam, they will be given a roll number. Okay. Then that roll number will be given as a code numbers. Okay. That is your A, B and C students roll numbers and the code numbers. Here the function f exists between this students to roll numbers, and again this g function exists between this roll numbers to code numbers. Then what you will get means B equal to f of A. That is, from this you are getting the roll numbers. B is equal to f of A and again C is equal to G of B. This is your function G from B to C. So you will get G of B. Okay. From here A equal to capital A, B equal to capital B and C belongs to capital C. Then from this we get C implies G of B equal to G of B is nothing but your f of A. This is the composition of two functions. Let f from A to B and g from B to C. Considering function g and function f from A to B and g from B to C be two functions. Okay. Then the composition of f and g is denoted by g composite f. Okay. Then the function is written as g composite f of x is equal to g of f of x. Clear? Here x belongs to set A. Okay. This is your definition of composition of functions. Okay. First what we have seen, that is the arrow diagram for this definition also. Considering A, B and C, function is from A to B is f and B to C is g. And here you get A as x and here to B what you will get f of A, and then what you will get in this, that is your f of x, taking here x, so f of x, and here you will get g of f of x. This is the definition for composition function. Next we can move on to the problems. Consider example 1.20. Find f composite g and g composite f when f of x equal to 2x plus 1 and g of x equal to x square minus 2. Okay, taking the functions f of x equal to 2x plus 1, g of x is equal to x square minus 2. First let us take f composite g. F composite g is written as f of g of x. Clear? So f of g of x, f of g of x, what is the value of g of x? Is your x square minus 2. Clear how I written? Next, f of x, this is f of x square minus 2. This is considered as your f of x, no? Okay. Now you write f of x value in the place here. That is f of x is equal to 2x plus 1. In the place of x, you are going to replace this value. Okay. Then you get 2 into x square minus 2 plus 1. Clear? This value you are going to replace in the place of this x. Then you get 2 into x square minus 2 plus 1, which implies 2x square minus 4 plus 1, which implies 2x square minus 3. Clear? Next is your g composite f. G of f of x. Okay? Which implies g of, what is it, f of x? 2x plus 1. Next your g of x is x square minus 2. In the place of x square, going to substitute this value. You get 2x plus. Next your g of x is x square minus 2. In the place of x square, going to substitute this value. You get 2x plus 1 the whole square minus 2. Expanding this, you get 4x square plus 1 plus 4x minus 2. Simplifying this, you get 4x square plus 4x minus 1. Clear? This is your f composite g and this is your g composite f. Next we can go on to the next example. This is your example 1.21. Represent the function f of x equal to 2x square root of 2x square minus 5x plus 3 as the composition of two functions. As the composition of two functions is nothing but f1 into f2. Like this we are going to represent this function. Okay. Now we are setting the values as we set f2 of x as 2x square minus 5x plus 3. That is, without the root, we are taking f2 of x as 2x square minus 5x plus 3. And f1 of x as root x. Clear? We are setting these both values. First, f2 of x is nothing but your without your root. And next, f1 of x is your root x. So, how we can write this? F of x. F of x is nothing but root of, what is the given value? 2x square minus 5x plus 3. And this can be written as root of f2 of x. This value is your f2 of x, so we are replacing here. Next is your, in root of f2 of x is we can write as f1 of f2 of x. And at last we can write f1 f2 of x. This is the representation of composition of two functions. Okay. Next we can move on to the exercise problems. This is your exercise 1.5. Okay. Here we are going to find the f composite g and g composite f using the given values of f of x and g of x, and also we are going to check whether f composite g is equal to g composite f or not. Okay. First problem is your f of x equal to x minus x and g of x is equal to x square. Okay. So we can take first f composite g. So f of g of x you will get f of g of x is nothing but your x square. Next f of x is nothing but your x minus x. So replacing this value in the place of x. Okay. Then you get x square minus 6. Clear? Next is your g composite f. G composite f is equal to g of f of x. Okay. Then g of f of x is your x minus 6 and g of x is equal to x square. So replacing this x minus 6 in the place of x, you get x minus 6 the whole square. On expanding you get x square minus 2 6 are 12x plus 36. So from this 1 and this is 2, from 1 and 2 f composite g is not equal to g composite f. Okay. Next we can see second problem. This is your second subdivision. F of x equal to 2 by x and g of x equal to 2x square minus 1. First we are going to find f composite g, which is your f of g of x, which implies f of g of x is f of g of x value is your 2x square minus 1. Clear? Next, f of x value is here 2 by x. So in the place of x you are going to replace this value. Okay? Then 2 divided by 2x square minus 1. This is your first. Next, consider g composite f, that is your g of f of x. Okay? Then g of f of x value is your 2 by x. G of x is your 2x square minus 1. Replacing this 2 minus x in the place of x, you get 2 into 2 by x the whole square minus 1. Simplifying, you get 2 into 2 square is your 4 divided by x square minus 1. You get 8 by x square minus 1. This is your second subdivision, second equation. From 1 and 2 we can say that f composite g is not equal to g composite f, because both are not same. So we can say f composite g is not equal to g composite f. Next subdivision. Third subdivision is your f of x equal to x plus 6 by 3 and g of x equal to 3 minus x. First, taking f composite g, f of g of x equal to f of g of x value is here 3 minus x. Then f of x value is here x plus 6 by 3. So replacing in the place of x 3 minus x, you get 3 minus x plus 6 divided by 3. You get 3 plus 6 9. So 9 minus x by 3. This is your first. Then g composite f is equal to g of f of x. You get g of f of x is your x plus 6 by 3, which implies g of x is your 3 minus x. Then you will get 3 minus x plus 6 by 3. Okay. On simplifying, you get 6 minus x by 3. Okay. From 1 and 2 we can say f composite g is not equal to g composite f. Clear? Next problem. Fourth subdivision. F of x equal to 3 plus x, g of x equal to x plus 4. So taking f composite g, you get f of g of x equal to f of g of x value is x plus 4. Then f of x plus 4 is nothing but, that is f of x is equal to 3 plus x. Replacing x plus 4 in the place of x. So 3 plus x plus 4 you will get. Then you will get x plus 4 plus 3 is your 7. Mark it as 1. Next, g composite f is nothing but g of f of x, which is equal to g of f of x value is your 3 plus x. Then you will get g of x is your x plus 4. So in the place of x, replacing 3x plus 4, 3 plus x, you get 3 plus x plus 4, you get x plus 7. From 1 and 2, both are x plus 1, x plus 7. Then you will get f composite g equal to g composite f. Clear? Next is your fifth subdivision. Fifth subdivision, f of x equal to 4x square minus 1, g of x equal to 1 plus x. F composite g, you get f of g of x, which is equal to f of g of x value is 1 plus x. Then f of x is 4x square minus 1. You replace 4 into 1 plus x the whole square minus 1. Simplifying, you get 4 into 1 plus x square plus 2x minus 1. So 4 plus 4x square plus 8x minus 1. You get 4x square plus 8x plus 3. Okay. Mark it as 1. And again, g composite f is nothing but g of f of x equal to g of f of x value is your 4x square minus 1. So, in the replacing g of x, you get 1 plus 4x square minus 1. You get 1 plus 1 minus 1 will get cancelled. Then you will get the answer 4x square minus 1. From 1 and 2 it is not equal. We can write it as f composite g is not equal to g composite f. Today we have seen section 1.9 in the 2 examples, and in exercise 1.5 first problem with 5 subdivisions. Okay, remaining problems we can see in next video. Thank you.
Dear students, I hope you all clear about today's video. If you have any queries, comment me in the comment box. If you like this video, then press like and share with your friends and don't forget to subscribe. Thank you. Meet you soon in next video. Bye.